Physics chapter 19, question number 16 to 19. I hope you can remember the equations that you have studied so far, and in these questions your knowledge on those equations would be checked. Question number 16. A mass secured at the end of a spring moves with simple harmonic motion. The frequency of its motion is 1.4 hertz. Right, and so the detail that they have given is there are two details here. It is in SHM, then you know the set of equations, and they have given the frequency. Then they are asking, write an equation of the form A equals negative omega squared x to show how the acceleration of the mass depends on its displacement. Right? So because they have given us given us only the frequency, right, and this particular equation A equals negative omega squared x, we don't have don't have any our value has not been given for omega. So we have to first figure out what omega is. Then the equation that we need to use is omega equals they have given the frequency, so we have to take an equation which brings together omega and frequency. So I hope you can remember the equation. The equation is omega equals 2 pi f. So we use that equation to find omega equals 2 pi f. Right, so you substitute the values. You know omega, you don't know omega, you know pi, and then f is given as 1.4, right? So 1.4, when you simplify this, you will get omega to be 8.8 per second, right? 8.8 per second. So now you have omega. So now the next step is going to be substituting that omega to the equation given. So they are asking, write an equation of the form A equals negative omega squared x. Right. So then you substitute the values to that equation. You have A equals negative omega squared x, and you got the value 8.8 per second. When you substitute those values, you will get A to be equal to negative 77.4x. 77.4x. Right? So that is the equation. That is for the answer for part A. I hope you understood that part. Then when you go to part B, calculate the acceleration of the mass when it is displaced 0.05 meters from its equilibrium position. So that means the x has been given. So we know we have an equation now. What is the equation? A equals my negative 77.4x. Now instead of x, you have to put 0.05. 0.05. A equals minus 77.4 multiplied by 0.05, and this will give you the acceleration to be 3.9 meters per second squared. 3.9 meters per second squared. I hope you understood. If you have any questions, please raise them. Then moving to question number 17. A short pendulum oscillates with SHM such that its acceleration in meters per second squared is related to its displacement x in meters by the equation A equals negative 300x. Negative 300x. Determine the frequency of the oscillation. So if you know the equation, you will be able to turn these things any way you won't, right? So you can connect these equations. So now in the earlier question also we saw two equations being used, that is omega is equal to 2 pi f. Then in the acceleration equation, a equals negative omega squared x, right? Negative omega squared x. So instead of omega, if we use 2 pi f, that is, let me show that, show you. So the original equation is omega equals 2 pi f. Then the other equation is a equals negative omega squared x. So instead of this omega, what we do is we put this one 2 pi f. Then we get a equals negative 4 pi squared f squared x. Did you understand that? Instead of pi, I use 2 pi f. 2 pi f squared is 4 pi squared f squared x. X is remaining here, right? So they are saying that it is equal to 300. A is equal to negative 300x, right? So then from that you can actually use a is equal to negative 300x. Therefore this whole thing is equal to negative 300x. So the only thing you do not know here is f. 4 pi squared f squared is equal to 300 per second squared, right? Because the x to x gets cancelled out. Let me show you. So you have to remember this equation, a equals negative 4 pi squared f squared x, right? We have we have the equation negative 4 pi squared f squared x is equal to in the equation they have given, it is negative 300x. Then this x to x gets cancelled out, as you can as well imagine. X to x gets cancelled out. Then you are left with negative 4 pi squared f squared is equal to negative 300. Negative to negative gets cancelled out. Then you are left with 4 pi squared f squared equals 300. Then you divide f squared is equal to 300 divided by 4 pi squared, and then you get the square root. Then this to this gets cancelled out, and finally you will get f to be 2.76 hertz. If you did not understand, please let me know. Right. Then question number 18. The pendulum of a grandfather clock swings from one side to the other in 1 second. So that means from one side to the other, from here to here, it takes 1 second, right? The amplitude of the oscillation is 12 centimeters. Calculate the period of its motion. So obviously you can you can understand that this is half of the period. 1 second is half of the period because it has to go back and come back to its starting position, right? So then it is going to be period is 2 seconds. 2 seconds. So part A, first answer is 2 seconds. Then the frequency, frequency is equal to 1 upon T. Then that is equal to 1 upon 2, which is equal to 0.5 hertz. 0.5 hertz. Then they are asking for angular frequency, omega equals 2 pi f. Omega equals 2 pi f. Then from that equation, you will get in rads per second, right? Omega equals 3.14 rads per second is the answer. If you have difficulties getting this answer, please refer to the first parts of this lesson, then you will be able to understand that. Then write an equation of the form A equals negative omega squared x to show how the acceleration of the pendulum weight depends on its displacement. So again, that is the equation that we have to deal with. Earlier also we did the same thing. A equals negative omega squared x, right? So here what is the let me discuss that in detail here. A equals negative omega squared x, right? A equals negative omega squared x, and they are asking write an equation of the form A equals negative omega squared x to show how the acceleration of the pendulum weight depends on its displacement. So weight means the force acting on is the acceleration of the gravity, right? So that means omega squared is going to be equal to gravity. Therefore A is equal to minus 9.87 x, right? Or else you can take A to be negative pi squared x, negative pi squared x, right? So one of these two equations will be the answer. Then part C, calculate the maximum speed of the pendulum bob. That is, once again we are referring to the earlier equations that you have studied. Omega xo. So we found the angular frequency, that is 3.14 multiplied by 12 is the they have given 12 to be the amplitude. So when you multiply those two together, you will get omega xo 3.14 into 12, then you will get 37.6 centimeters per second. Omega xo, I hope you can remember this equation. This is the equation for maximum speed. Then you get 3.14 into 12 displacement, that is the amplitude, that will be 37.6 centimeters per second. Then part D, calculate the speed of the bob when its displacement is 6 centimeters. 6 centimeters. So once again we discuss these equations in detail. So go back to those equations. If you find it difficult, study that from the beginning itself, then you will not be confused. But if you are still confused, then let me know. I will explain it a little bit further. So the equation that you have to use is V equals omega, then square root xo squared minus x squared. right? So then you substitute the values. V equals omega is 3.14, then square root 12 squared minus 6 squared. When you simplify these, you will get 32.6 centimeters per second. 32.6 centimeters per second. Let me know if you have difficulties. Question number 19. These questions simply check your understanding on the equations that you have studied so far, nothing else. Question number 19. A trolley of mass M is fixed to the end of a spring. The spring can be compressed and extended. So we are compressed and extended. We are thinking about springs, and you should remember Hooke's law. Right? So that means the acceleration is proportional to the force. Right? And then as a result, acceleration is proportional to x as well. And the force acts in the opposite direction to the displacement. That is something that you need to know. Right? A trolley of mass M is fixed to the end of a spring. The spring can be compressed and extended. The spring has a force constant K. The other end of the spring is attached to a vertical wall. So it might help you to draw this as a diagram. And when you draw it as a diagram and refer to all the equations and try to understand what the details that have been given. So if you write down all the details, all the information that have been given, then you will be able to figure out what exactly they are talking about, or what exactly they are asking from you. So if you know what they have given, and if you know what they are asking, then you will be able to use the equation which contains all of the details. The trolley lies on a smooth horizontal table. So the word smooth suggests that there is no friction. You don't take friction into consideration. The trolley oscillates when it is displaced from its equilibrium position. Show that the motion of the oscillating trolley is SHM. Show that the motion of the oscillating trolley is SHM. So that means, once again, the details that I gave you earlier. So there is a restoring force Kx, that is from Hooke's law. A is proportional to F, therefore A is proportional to X. The force acts in the opposite direction to the displacement. So these are all properties of SHM. So as a result, we can see and we can say that it is acting, forces that are acting results in SHM. Then show that the motion of the oscillating trolley is SHM, that is one. Show that the period t of the trolley is given by the equation t equals 2 pi m square root m upon k. So here they are actually making you use all the knowledge that you have, right? So what are the equations that you know for acceleration? Right? Acceleration is equal to negative f upon m from f equals ma. Right? A equals negative f upon m. Right? So then you know that f is you can, from that you can take negative kx. Acceleration is equal to negative kx that has been given, divided by m. Right? And all of this is equal to negative omega squared x. So you know all of these details. Right? Then from all of this, right, when you combine these two equations, right, you can actually take for omega squared, you can take an equation omega squared equals k upon m. Right? So when you write this stuff, you will understand. If you have doubts, again tell me. You will get an equation for omega squared is equal to k upon m. Then omega is equal to square root of k over m, right? Then you know another equation for you know another equation for frequency. Frequency is equal to omega upon 2 pi, and then which can be equated to f equals 1 upon 2 pi, right? 1 upon 2 pi multiplied by k upon m, square root k upon m, right? So from this one, then because t is equal to 1 upon f, then you put it down under, then you will get the opposite of that, the other side rather of that. t equals 1 upon f. Then you flip the other way around, you will get earlier you had 1 upon 2 pi square root k upon m is equal to f. Then 1 upon f means the other side of this. 2 pi square root m upon k is the answer, and that is exactly what you needed. I hope you understood. If you have any further questions, please ask me.